Welcome to the session on approaches to governance and, sorry, I'll go back here. Wrong direction. Approaches to governance and access control in Hyperledger Fabric. My name is Rakhmilevich. I am part of the development organization in Oracle responsible for our blockchain cloud platform, which is based on Hyperledger Fabric. We have announced general availability this summer in July, and have worked with a number of customers in a number of projects who are deploying blockchain networks in a real business environment and running into some of those requirements that I'll talk about today and some of the approaches that we are working on with those customers on addressing those problems. And there's some, if you want to follow up, my contact info is at the bottom here. So we'll talk about some of the items which are kind of futures in Oracle's roadmap, so the safe harbor. What I will touch on briefly is how Oracle's working with enterprises to help adopt blockchain, and then talk about the examples of the actual projects where we are finding the need for governance, the need to be able to solve those problems on-chain as opposed to off-chain, and also access control. Our platform is built to provide enterprise-ready capabilities that allow customers to basically get started in a cloud environment and have the entire blockchain network provisioned for them in a matter of a few minutes with a few keystrokes, leveraging Oracle Cloud Infrastructure. So it's very quick, very easy to use, and it has a lot of enterprise-grade enhancements beyond the initial open source capabilities that Fabric provides. We've done a lot of integration work from REST API perspective, SDK, as well as various Oracle application integration points to ensure that customers can very rapidly begin to use blockchain in real business environments and integrate variety of data sources to both drive transactions on the blockchain and, in fact, query the data on the blockchain from a variety of backend, systems of record, whether it's ERP systems, human resource systems, customer experience systems, etc. And we've been doing a lot of work with customers who are in the process of building consortia, who are actually trying to pull together organizations within the ecosystem to create those consortia. And I'll show you some of the examples. There is a number of initiatives across various industries. Of course, everybody's been talking about financial sector, and we're beginning to see a lot of other industries actually taking advantage of blockchain capabilities in the last 12 months or so, certainly in supply chain related space, whether it's manufacturing, distribution, transportation, logistics. See a number of use cases in public sector and government as well as healthcare, which is quite interesting actually. And I'll highlight a couple of those examples as we go through. When we talk to enterprise customers about blockchain, we find that certain things about blockchain really stand out that appeal to customers around data integrity because of the consistency of the ledgers in the distributed, decentralized environments, ability to have extremely high resilience and durability of the data, process integrity. You can trust the transactions because you know that when they are committed, there is consensus that's been reached and the transactions themselves have been digitally signed for non-repudiation and so on. So all of that, bottom line, gives you the ability to simplify significantly the ecosystems that customers are working on around the ability to do faster transactions that, in fact, avoid some of the inter-day, inter-week settlement and reconciliation processes that require offline batch runs or data file transfer, etc., and in fact turns it into a near real-time transaction. Ability to lower costs because of removal of third-party intermediaries and the overheads involved, and the ability to automate significantly more in a business-to-business environment because you now have data available from multiple parties in a single source of truth. And so you can, in fact, validate the data much better. You can trigger events. Very simple example, when you are in a supply chain environment and you have purchased order items verified against invoices, against shipping, you can then determine, in fact, that everything has been sufficiently mapped so that you can go ahead and trigger a payment event. And many, many other examples of that, right, around reconciliation and business-to-business environment. So when we talk about blockchain models, we obviously see a very broad spectrum out there, right, starting with public blockchains like Bitcoins and Ethereums out there that are anonymous to permissioned blockchain, which is primarily what we are focusing on, and most of our business enterprise customers are really interested in permissioned blockchains where the identities of users are known and where you, in fact, have legal entities that are participating. And it could be a private blockchain with sort of different divisions within a single organization, maybe multinationals run those things. But what we're also beginning to see a lot of what we call in consortium blockchains, and this is kind of the main focus, where you have multiple companies independently joining and participating in the blockchain. And there are certain requirements that they have about running the business, how you're going to manage all of the organizational requirements around adding members, deploying chain code, creating channels, and many other organizational things that are important in this environment where multiple companies are working together and there is nobody in the lead, right? That's ultimately the question here. And of course, we see some emergence of what's called public permission blockchain, kind of a hybrid model where typically the people who update the data, the writers on the blockchain, are permissioned entities, but then you have also public access for read access. And public is in quotes here because public could be controlled through some other means. It could be very open, or it could be through some access control system, maybe all citizens of Switzerland through some kind of a national system, or maybe if you are in financial services, maybe all participants in the market or something like that. But the main focus today is consortium blockchains. What we're finding is that many customers most customers would fall, I would say, in these two buckets, right? They're either still experimenting and they want to do it fast. They want to try a use case and move on to the next one if this one doesn't pan out. So they need to be able to provision very fast, configure easily, develop and integrate fast. And then we have a number of enterprises which are ready to move forward into production once they've determined there is a valid use case, or more than one perhaps, that they have discovered. So they need all of the enterprise-grade features, performance, resiliency, security and confidentiality is extremely important. At the end of the day, we're talking about business processes. Enterprise integration, particularly making it easy, plug and play, so you don't have to spend an inordinate amount of time integrating every single system of record, day-to-day supportability, governance, and so on. So Oracle Platform provides a lot of these capabilities built in our cloud environment. We use Oracle Cloud Infrastructure to provide all of the dependencies, and then Hyperledger Fabric with Oracle enhancements on top of that, providing a great deal of integration capabilities through REST APIs, SDKs. Oracle Integration Cloud, OSC, provides enterprise adapters for plug-and-play integration to 50-plus different applications in the cloud or on-premises, Oracle and third parties. So all of this is pre-assembled. All of that is available basically through a simple, quick provisioning, 5-10 minutes, and it's up and running. It's open because it integrates not just within the Oracle ecosystem, but with external Fabric nodes. So we have had customers prove this by using their own instances of open source Fabric together with Oracle Cloud. And in fact, we began to work with some of the other members of Hyperledger to do the same thing recently. It's an environment that supports plug-and-play integrations, as I mentioned, with ERP systems in the cloud environment, on-premise environment, Oracle and third-party. Enterprise-grade around things like high availability, resiliency, built-in backup, zero downtime managed patching, and so on, and automated DevOps, so that customers can focus on the application value and not on the infrastructure managing the platform. We kind of take care of all of that through the managed path. We have about 96 or so customers on the platform currently, over about 400 trials. And many of the examples you see on the right here are about to go into production, actually. About half of this are going to be in production in Q1. Funds transfer, loyalty programs, provenance tracking in food, in particular maritime shipping, documentation exchange in maritime shipping is a very onerous task. Franchise network between the franchise owner and franchisees, and a number of other examples in public sector, healthcare, and so on. So there's some of the announced customers, just to share some of the names here. You might or may not recognize that have publicly announced, and many others are working through this. So what we see is that in many cases, we have two types of consortium models that are being stood up. There is what's called founder-led consortium model. In the Hyperledger Fabric environment, you have an ordering service that typically is operated by a founder, somebody who might be a head of a supply chain consortium because they're a major buyer. You've all heard about, let's say, the IBM, Walmart, food safety projects. So Walmart basically runs this consortium. They are responsible for the ordering service, and everybody else kind of joins in as participant. You might have a loyalty system led by a large bank, and all of the merchants participating would be participants as well. But the bank would operate that and would make key decisions, deploy the smart code, create channels, and set everything up. The role that the participants have in a founder-led system is somewhat minimal. They still own their peer nodes. They sign the transactions, and they might participate in some endorsements, but they don't really make the core decisions about the governance here. Whereas on the right-hand side, we see a few examples, and not as many, but a few examples emerging of decentralized democratic governance systems where, for example, you might have a multi-brand loyalty network where multiple companies are participating, sharing, let's say, loyalty points on a blockchain network. But each one is running as a separate business, and there might be a company that stood up the network to provide basic sort of a bootstrapping mechanism and technology, but they are not necessarily the governing body, right? The participants have a governing body that they want to create, and then they want to make executive decisions about that. And the second one is a global shipping business network, which is a particular network that was recently announced by some of our partners on Oracle blockchain in maritime shipping. And I'll talk a little bit more about that because it's a great example of the requirements that are emerging in governance for decentralized networks and how we're trying to address them. So here's two different examples of solving similar problems in a different way. CargoSmart is a partner of ours, a customer that's in maritime shipping. They work with a very broad ecosystem of companies from shippers to freight forwarders, ocean carriers, non-vehicle owner operators, ports and terminal operators and so on, customs and such. And ultimately, they have a lot of documentation that has to make its way through. Each shipment might require 20 to 30 documents, often multiple versions, updated and signed by different participants in the system. There are often delays, often disputes in the system, and at the end of the day, the ships cannot pass inspections, customs cannot get the container out of the port because some documentation is missing, they end up paying fees, and all of that stuff. So CargoSmart created this document exchange to unite all of these participants in a single blockchain ecosystem in order to provide ability to trace all of the documentation, link all of the documents on the blockchain, provide a tamper-proof audit trail so that it's clear exactly who touched the document when and why, and ultimately collect the data, relevant data inside the document into the metadata that's visible in a blockchain record for context-based document validation. So in this particular example, CargoSmart essentially is a founding instance and everybody else is joining, and they're operating this. They are the application vendors. They're deploying the chain code and all the surrounding application components. They're managing the identity and authentication. They're managing the process of who's joining the network and so on. Now, the second thing that they've done is say, let's move completely to the opposite side of this spectrum into a decentralized model. And so with their help, we've started what we call a Global Shipping Business Network. It's a maritime shipping alliance that was announced at China's Import Expo in November that involves 5 of the major ocean carriers that are responsible between them for about 1/3 total ocean container shipping capacity, and 4 of the 5 largest terminal operators around the world. The purpose of this blockchain environment is to be completely decentralized, completely open. They're going to have a variety of data sources on this blockchain, starting with what's called titles on the left there, on your left. And this is documents, all kind of documentation. Following that, putting a variety of events and tracking that on the blockchain as well. However, every participant, the 9 listed, and all of the ecosystems that they work with can actually build and deploy distributed applications on top of this data and provide value between themselves. So if you have a large steel company working, let's say, with conscience on ports, and they have a particular problem because, as I just heard, they can schedule trains that take the call delivery from the port into their factory because they don't know exactly when the ship arrives. And they want a blockchain app to help them do that and coordinate the data between their systems and the port and the tracking. The data will be available on the blockchain. They can create an application to access that data and monitor it and manage it. And so you have an environment where there is a need for companies to be able to independently define how they add members, how do they deploy chain code, and so on in this environment. Here's another example in trade finance, working with a company called Exafort, which is an ISV that's building a blockchain for trade finance, connecting into the major ERP systems, starting with Oracle ERPs like NetSuite, which is a small, medium business ERP for around 40,000 customers that are using it in small, medium enterprises, and Oracle E-Business Suite at the bottom, which is for very large customers, major Fortune 1000 companies. And in between, you have a whole bunch of banks, issuing banks, advising banks. The process model here is very straightforward. When you want to get a letter of credit, you have to fill in a lot of information, send it to the bank. Instead of doing it manually, you can now do it using the Xford plugin into NetSuite directly from ERP system, so data is all pre-filled. The process is managed. It's all sitting in the same exact space where the ERP user is operating day to day. They don't have to go do something separate. It's all built in and packaged, and it can flow to the bank, ultimately to the seller, and they can manage this process. But the point here is that the consortium is going to involve a lot of buyers and sellers and a number of banks that are going to be participating here as issuing and advising banks. Again, they need to determine how to manage this, and certainly Xford as an ISV is willing to provide the applications. They don't want to take on the role of operating this and determine, in fact, who is going to be added and how. And here's another example here. In electronics distribution industry, there is something called ship and debit claims. Ship and debit claims means that when you're ordering electronic components, you don't quite yet know how many you're going to sell, and so you're paying for them based on a fairly high starting price. As you sell more, there are all kinds of conditions that the sellers create. They say, okay, if you sell this many in this time frame to this particular buyer, we'll give you a refund or discount. Right? That's called ship and debit claim, and then ultimately the data has to be tracked back, and those claims have to go back to the manufacturers, to the sellers of the components, so that they can refund to the distributor. It's extremely arduous manual process. Tens of millions of dollars for a particular distributor are sitting in unpaid claims. It's directly impacting their bottom line because they just can't coordinate the data. So they're putting in a blockchain solution to be able to automatically track all of the shipments and then be able to automatically trigger those claims going back to the sellers. In this environment, we're working with Infosys as a partner to deploy this, and the idea then is to integrate with the distributor. In this case, they're going to be starting the blockchain, but the sellers and the buyers, major OEMs, major electronic suppliers, are all going to be members of this blockchain. Governance, again, becomes an important point. So what we really need here, right? When we are moving from a founder-led network to the centralized governance model, you now have to have each individual member deploy the chain code, determine how they're going to work jointly on adding new members. This is going to be an email sent around. Everybody gets on a conference call, and they decide, okay, here's a bunch of new members we want to add, and do we agree with that or not? It's certainly not going to be a straightforward process, and it will impose a lot of administration costs on the consortia because it's not automated. So what we are working on is to propose an on-chain governance model that will support voting-based policies. From what we saw, from what we looked at, there are 3 levels that immediately come to mind. At a network level, you want to be able to control the process of adding or removing organizations. At a channel level, you want to control how you're creating channels and who the members are of the particular member organizations in a particular channel. And then at the chain code level of smart contracts, deploying and upgrading chain code. If it is a decentralized and democratic blockchain environment, then if somebody is going to upgrade to a new version of chain code, you want a review process. You want to ensure that all other participants have a chance to review the changes being proposed. At the end of the day, that code is going to be running on their nodes and creating endorsements signed by the digital certificate. They are ultimately responsible. So they want to have a review capability, and they want to be able to then say, yes, we agree with deploying this chain code or not. But there may be situations where in a very far-flung network, some members will see that responsibility to some others. And so we foresee an environment where you have voting and non-voting members in a consortium environment, and the voting members basically make the decisions on behalf of the other non-voting members. Now, the other process that's very important here is how do you collect the votes, tabulate them, and then execute on the actions, downstream actions required by those votes, right? So you want chain code running that is in fact going to be able to go through the endorsement process, ordering process, and so that you can get all of the policies defined on-chain, the results of the voting tabulation maintained on-chain as well, using a governance channel that will allow you to then have all of the data available for auditing. All decisions really need to be audited in order to ensure full transparency. And then, of course, you also want to have some agents that allow you to automate this process. If you have a vote on adding a particular member, there is a transaction proposal, and sufficient number of votes have been gathered based on whatever the policy requirements are, you want to automatically go ahead and do that. You don't want to then depend on somebody manually going in and clicking through the process of adding a new member. So this is infrastructure that we are working on, and it's essentially going to support some key operations from the initial capabilities that we are going to be releasing Adding a member, so there's going to be a transaction that's going to be proposing to add a member, and there's going to be different roles, voting and non-voting roles. And there are going to be policy setups that will allow for a number of votes. The policy is going to essentially say how many votes are required, and perhaps if there is any mandatory votes. Very similar to what's currently defined as endorsement policy types in chaincode environment. We're also going to have operations involving channels, adding a channel, defining membership, policies around adding and removing, and also policies for installing and upgrading chaincode, and mechanisms involved that allow people to actually view the chaincode before the vote, and then ultimately provide a vote and the agreement on whether to upgrade to a particular new version. We also believe we need to have policies for adding a new policy, right? So there's sort of a little meta here, but we need to make sure that you can add new policies and have votes available for making a decision on that process as well, or modifying a policy. So we are providing essentially 3 capabilities here on top of Hyperledger Fabric environment. A governance module, and that governance module will be based basically as a client application using the Fabric SDK. It will sit on a governance channel. It will basically connect to the governance channel to execute transactions. And we will have the peers that have voting status as read-write members in that particular channel so that they can execute the chaincode that then is specifically built to handle voting and handles the evaluation of policies. The chaincode itself is going to dynamically read the policy from the governance channel, and then it will either trigger a vote event, or it will have methods that enable it to actually collect the votes, tabulate them, and it will check every time a new vote comes in if the policy has been met. If I have a policy that says on this channel with 10 members, I need 7 votes to take certain action, every time a vote comes in, we'll check, do we have 7 votes already recorded? And if so, then we'll trigger an event for the downstream agent. The method in this chaincode that we're going to provide, going to have a basic create network initialization method to define the initial policies and the voting members, starting with the founder, and then others could be added. Create proposal, which is essentially creating a new proposal based on the policy and certain resource groups, and it will emit the events so that the client applications know that there is a vote outstanding. A vote message to actually record a vote for a particular proposal key that's recorded on the chain, and evaluating then if the policy requirements have been met and if an agent to automate the process can be triggered. And a query function as well, so you can check and see what the status of a particular proposal is. It's kind of the basic framework that we think is going to help solve not all the problems out there, but provide at least an initial starting point for dealing with governance on-chain so that in most of the consortia environment, people can move from offline, kind of out-of-band processes to something that is more automated. Algorithmic, as Brian said. Here's an example of how this would work when you're installing a new chaincode. So in our environment, and this is an example based on our particular console, we have a UI where we have a chaincode tab. There is an action there to deploy a new chaincode. There's a wizard that provides capabilities to specify all of the parameters necessary when you're installing a chaincode, which peers you want it on, which channel, endorsement policies, etc. In fact, if you want to see this live, I have a demo tomorrow at 2 o'clock in the theater to show Oracle blockchain environment and console, and I can get into that a little bit more details. But essentially, the wizard will provide an option to send a request for vote, right? Rather than just install it by yourself in your particular peer. So sending for vote will then use create proposal method to be able to put a proposal on chain, and the chaincode will then trigger the events. The policy will be defined on that same channel, and then chaincode will be shown in pending status while the voting process is going on. When the voting members register their vote, they're calling a vote method, and that will be available through an API. We will extend the SDK to do that as well as provide REST API, and it's easy to build some clients if you want a user interface for that. Ultimately, when you tabulate sufficient number of votes, then an agent is triggered to automatically install this chaincode on the channel's peer nodes. Now, this is quite a bit different than what happens today. In the current environment, if you want to install a new version of chaincode, every single member has to have the administrator go through the process of installing chaincode on their node. And we've been hearing from, I can tell you how many customers, how painful that is. At the same time, they're saying, look, this node is running, we own it. It might be running in Oracle Cloud, maybe in their data center, whatever, but it's still their node and they're responsible, so they want to have some controls. They don't want to say blindly just go and let somebody else install code. What they want is a process where they have ability to have it done automatically, but after a review and voting process. And so what we've done is automated it, but not blindly. We created a process that allows you to essentially take a vote. You have ability to then review it whenever you need to, and then you can actually register your vote, and then it will happen automatically once sufficient number of participants have agreed to that. So that's a little bit on governance and some of those things that we've been looking at and how we're planning to move ahead with this. The other area that is somewhat different but also related to enterprise requirements is confidentiality and privacy. There is a great tension every time we get into conversation with an enterprise about how great and valuable transparency on a blockchain is, single source of truth. Everybody can see all the data. And then you're sitting down with a purchasing office and it says, wait a minute, what do you mean everybody can see the data? It's a purchase order for a particular vendor. I don't want other vendors to see this purchase order. Or I'm sending invoices to somebody else. That's confidential, right? I want it to be between the two parties involved. So I don't know about you. I've been in many of those conversations, and every single one gets into this point where ultimately people realize that there is this tension and you have to solve it. Now, there are some approaches today in Fabric that try to do that. There is a channels mechanisms where you can subnet the ledger and participants by channels. That sounds great, but it's kind of coarse-grained. You end up with proliferation of channels if you're not careful. You want to have a network of 10 members. If you want bilateral privacy, that's 100 channels. And if you have 1,000 channels, 1,000 members, participating organizations, guess what? You're going to have 1 million channels. That's not really very manageable. Since the Fabric 1.0 came out, there's been some additional approaches using access control mechanisms, attribute-based and role-based access control. And so we'll look a little bit at that. But let's first a few examples. So we have a customer of ours who is in electronic data interchange, EDI space, and they do a lot of electronic invoicing. In particular, a large customer base of theirs is franchise owners. They're based all over Europe. They're implementing this particularly in Spain right now, where they want to be able to connect franchise owners and large number of franchisees using blockchain. When the invoices are sent today, often there are disputes through the EDI process. Did they get it in time? Was it a proper invoice? A lot of things get unpaid, and so there is normal business friction there, right? So the answer is put it on a blockchain so everybody can see the same exact source of truth, audit trail, non-repudiation, everything's timestamped, you can't have a dispute. Well, that's great. So they're putting it on a blockchain, but now the question is, how do you manage the confidentiality? I mean, you're sending an invoice from a franchise owner to a particular franchisee, company X. You don't want others to be able to see it. You don't want to create a separate channel for that pairwise relationship either, because you go to then have a proliferation of channels. That's a challenge. Here's another one in healthcare space. So we have a partner in US, HealthSync, that is working on an application that will support remote patient monitoring. When you have a patient who is admitted to a hospital with congestive heart failure, heart attack for all of us lay people, or pre-heart attack kind of symptoms, and they get treated at the hospital, then they get discharged home. They're well. But often there is a significant readmission rate. In fact, it looks like around 27% of those people who have been discharged get readmitted back to the hospital because something happened after the fact. There is billions of dollars in costs, but more importantly, there is significant death rate, people who are readmitted but too late. They can't be helped. So this particular company is trying to solve that, and they're trying to solve it by having people be discharged to go home with a set of devices. And so they have ability to collect the data, report it using IoT and blockchain together to a number of participants who can then monitor this data. So you have a blockchain that involves basically a distributed care team, a patient, their physician, maybe there is another attending nurse from another organization, maybe there is an analyst sitting somewhere, maybe somebody, a company that's providing a service and so on. So obviously there is a great deal of importance attached to healthcare privacy. And in US, the HIPAA regulations are very strenuous. You have to make sure that you have patients' concurrence to release the data, and also that only people who are entitled to see particular data can see it. So we've been working with this particular company to look at how we can provide fine-grained access control mechanisms to ensure that only the relevant parties can see relevant data. Right? It's not just about tracking the HIPAA signatures and all of that stuff, which is good, but more importantly, how do you track the data that's being submitted and popped up on people's dashboards, right? I mean, a nurse sits in front of a like network operation center, right? It's what's called, in medical terms, telemetry, where you have people sitting at home, the data is being reported, alerts popping up, and they're taking action based on that, at least notifying physicians and so on. It's an area that's actually a number of hospitals are beginning to pioneer in the US. Not necessarily with blockchain, but blockchain certainly is an important enabling technology here. So the fine-grained access control is really becoming very important. And as I mentioned, the existing mechanisms like channels are too coarse-grained, so that's not going to be an answer. Attribute-based access control is a good initial step where you essentially have X509 certificate optional fields used to record certain attributes, and then chaincode can query those during execution and make decisions based on that. The only problem is there's no standard definition of what those attributes are. You're going to have an agreement that's required between the users and chaincode developers to determine what attributes to code for, right? So that's going to be a little more difficult. Fabric actually introduced in 1.2 another mechanism for access control, but that's management function focused, right? So it provides access control around things like installing, aggregating chaincode, getting information, getting blocks, getting transactions, getting channel information. It does not help when I want to say, I have this chaincode and there is this function and I only want that function in my chaincode to be invoked only by certain participants, or I have a particular key or fields inside the attributes inside the key, and I want updates to those keys only be provided and allowed to certain participants. So basic requirements that we see is ability to have developers, chaincode developers, be able to control what users can access the functions and resources related to a particular chaincode. You want to have dynamic list of entitlements. Basically, if any of you are familiar with authorization controlled access control in an enterprise environment, you have entitlement management systems. That's what they do all day long. The question is, how do you provide that in a blockchain environment? Part of the answers that we explored was, well, you have an entitlement management system. Let's call an API in that entitlement management system from the blockchain chaincode and get a response back and manage it all externally in an external security manager. There's a problem with that. There is latency involved, but more importantly, you have non-determination, right? You have chaincode executing on 10 peer nodes, and some of them might get a response and others may not because of the state of the network. And they're going to make different decisions, which is not really good in a blockchain environment. So what we really want is on-chain entitlement mechanism where the changes are recorded on-chain, the access control lists, ACLs, are recorded on-chain, and there is ability to essentially update those entitlements in a way that does not lead to non-deterministic execution. So we're implementing a chaincode library that will provide API for access to do access control checks, and also some chaincode that will essentially manage this on-chain. Users will be able to initialize a list of resources, initial ACLs, when they deploy the chaincode. There's going to be a meta access control list to determine which users can be authorized to perform ACL operations, which is adding a new ACL, registering a new resource, adding a new user, and so on. And sharing that across channels is going to be very important because in many cases you might have the same chaincode, we're just sharding the ledger in terms of scaling the data space, but using the same chaincode. So library functions will provide the ability to create and delete resources, and resources will be generic. So it could be a chaincode function name, it could be a field name or key name that you're updating. There will be ACLs associated with them. We'll use a concept of groups to create and delete groups based on identities. So it's going to be a group managed environment. Identities will include 509 CN, subject common names, organizational units, and orgs, starting with the certificate identities and then expanding that beyond this aspect. Ability to create ACLs, add ACL to a particular resource, because the same ACL might be added to multiple resources. You want to make that orthogonal. And then the ability to get members, get lists, and ultimately the check access API call from the chaincode to be able to determine whether a particular resource has particular type of access, read, write, change, delete, etc., to a particular, for that particular resource. So this is a capability that we're working on, and we think there's going to be a lot of value in leveraging this for those enterprise customers that are going to have confidential data that they need to protect, and they want the chaincode to provide on-chain entitlement mechanisms. Now, there is intersection here that's quite interesting between governance policy and the entitlements or access control, which is that if you are going to have a chain code deployment process, and that's going to be based on governance policies, how many votes do you need to deploy particular chain code, part of the deployment spec is going to be what is the initial entitlements, what is the initial resources being defined, and who's going to have access to those particular resources in the consortium. And so voting will, in fact, look at that as well, and as you're reviewing the chain code, you will also review the deployment spec and determine if you agree with a particular set of ACLs being defined. And then, as you want to update those ACLs, those entitlement updates will be subject to the vote of the members as well. So to summarize, and now we're coming up on lunchtime here, we see this significant shift, I think, from blockchains that over the last couple of years were mostly founder-led, the emergence of these decentralized governance blockchains, democratic blockchains. And we really need the governance mechanism so that things like adding members, creating channels, deploying chain code can be automated, right? So you have track record, you have audit log. We all talk about how great blockchain is in ensuring full transparency, non-repudiation, tracking of everything that happened. But everything that happens is implemented by the chain code. And the tracking, now, of course, chain code install is a system function, and there is system chain code to do that. But it's being tracked essentially on a system channel, and it's not something that's easily accessible. So the idea here is to provide an auditable mechanism for on-chain governance and provide voting policies that allow customers to be able to, in a decentralized environment, take votes of the voting members, perhaps subset of the full membership list, to be able to control all of those operations. And then added to that is a fine-grained access control mechanism that we think is going to help a great deal to maintain business confidentiality, whether it's regulatory requirement in many industries. You need to protect your customers, even if you're in an alliance, like in the Global Shipping Business Alliance, very strict requirements that vessel carriers, freight forwarders can cooperate and exchange a lot of data, but they're not allowed to share the shipper information. And of course, in financial services, you look at proliferation of particular type of blockchains that claim greater capabilities around data privacy, like Quorum, Corda from us3, and so on. Their whole, basically, reason for being is the ability to provide private transactions. And so we think that it's time that in a Hyperledger environment, we stepped up to those capabilities and ability to provide private transactions so that whether it's financial space, healthcare, government, supply chain, what have you, all of them can, in fact, move forward and transact real business operations, real confidential business data on a blockchain with all of the values that it provides, but at the same time, the assurances that the data can be protected and business confidentiality can be maintained. So I'll pause here, can take a few questions. And if you want more information on Oracle blockchains, there are some URLs up there. The first one is just general landing page with all kinds of useful information and custom examples. The second one, cloud.oracle.com/blockchain, is actually the landing page for the blockchain cloud service where you can go and sign up and explore this live. And then we have a developer page as well. Please.
This looks fantastic. Is any of this going to be available open source for the community, or is only on the private?
So we are going through some process with Oracle legal and so on. They got approvals to contribute, and looks like we're getting good progress there. So some of this will be contributing as well, some of the capabilities, because we think there is value in everybody being able to leverage this capability. If the networks are going to be decentralized, many customers might be using Oracle, but some may be using other environments, other deployments. And so we want to make sure that the governance capabilities, access control can be shared.
So in your experience, what percentage of real-world use cases for permission blockchains have Byzantine fault tolerance as a hard requirement?
Byzantine fault tolerance has not been a strong requirement. I would say maybe 20% or so from what we've seen so far. In many cases today, they're perfectly happy with the current consensus mechanisms, Kafka and so on. But we think there's going to be, that number is going to be growing. I suspect that percentage will grow as we get more production deployments. Any questions here? All right, well, thanks. And I'll be around today, tomorrow. Feel free to find me. And tomorrow at 2 o'clock, I'll be doing a little demo on Oracle Blockchain Cloud Service in the theater sync room. Thank you.